Okay, so now we're going to talk about a very useful and helpful law called the law of sines. So take a look at the triangle that we have here and notice this time it's not a right triangle, it's just a triangle. And what the law of sines says is that, well, first of all, if we have these angles marked A, B, and C, notice that the sides that are opposite from each one of those angles. So this, just looking at angle A a moment, the side that's opposite from it we have labeled lowercase a. And same thing with angle B. The side opposite from it is lowercase b, and angle C, the side opposite from that is lowercase c. So using those labels, looking at this triangle, what the law of sines says is that the sine of angle A over side length of A is equal to the sine of angle B over or divided by the side length B. And that can be used with any combination of angles and sides. So notice sine of angle A over A equals sine of angle B over B. I could also combine angle A and angle C and side A and C. So sine of angle A over A is equal to sine of C over C. And lastly, the last combination, sine of B divided by B is equal to the sine of C divided by C. So the nice thing about the law of sines is that we can use it to find lengths or sides or angles of any triangle, not just a right triangle. So the trig ratios were great, except they were only useful in right triangles. The law of sines can be used in any triangle. So let's see how the law of sines works. So if I take a look at this example, well, this should look familiar. We, a moment ago, found the length of AD. And if you recall, it took a couple steps because we had to focus on the two separate right triangles and we had to find the length of AC, which then helped us find the length of AD. Well, using the law of sines, we're going to find the length of AD all in one step. So first of all, with my diagram, I already have the triangle labeled ABD. So I'm just going to go ahead and label the sides opposite those angles. And by the way, I can just substitute the D where we had the C in the law of sines. So I'm going to call the side opposite angle D, D. I'm going to call the side opposite angle B, B. And I'm going to call the side opposite angle A. And again, notice I'm focusing on triangle ABD, which is not a right triangle. So I'm focusing on that triangle. So I have to decide here which ratio I want to use. Well, obviously, if I'm looking for AD, which is length B, then I definitely want to use that piece. So I'm going to use the sine of 50 degrees divided by the side that's opposite of that, which is the one we want, which is AB, which is AD, which we're calling B. So I want to use that one. Now, I could pick to pair up with that to make my proportion that's equal to. I could either use angle A with side A or angle D with side D. Well, if I used A with A, I don't know angle A's measure and I don't know side length A, the side length of A, but I do know angle D's measure and the side length D. So that's the combination that I want. So that would be sine of 59 degrees divided by side D's length, which is 27. So now I have enough information. I have 3 pieces of information and I need the 4th. So I'm going to go ahead and cross multiply and solve for B. So 27 sine of 50 degrees is equal to the sine of 59 degrees. So sine of 59 degrees times B. So I want to solve for B, which means I'm going to divide both sides by the sine of 59 degrees. And when I do that, I'm going to get the length of B, which is the side length of segment AD. So in the calculator, I am typing 27 times the sine of 50, and I'm dividing that by the sine of 59. And when I do that, I'm getting 24.13 approximately. These are centimeters. And that is the length of segment AD. Okay, and by the way, that is the exact same answer that we got when we did this problem in a couple steps previously. Okay, so it does save us some time. We get the length of segment AD all in one step. Okay, let's take a look at the next example. Okay, so here we have another triangle, and it says we're supposed to find the side length of A. Okay, so I'm going to label my sides. So A is what I want, B is the one that's across from angle B, and C is the one that's across from angle C. So again, I want to use the information where I have the most information. So I'm definitely going to be using the 22 angle C and the side length. So I'm saying, using the law of sines, saying that the sine of 22 over top of C, which is 41, is equal to the sine of, and remember what I'm looking for side length A. So I'm going to use the 31, which is angle A, and that's going to be divided by A. So I'm going to cross multiply. So A sine 22 is equal to 41 sine of 31. And I'm going to divide both sides by the sine of 22, which is going to get me A. So in the calculator, I am typing 41 times the sine of 31 degrees, and I'm dividing that by the sine of 22. And when I do that, I'm getting approximately 56.40. And these are feet. Okay, so that's A. Okay. Now, if I sometimes we can use the law of sines to find angle measures. So we're going to do this problem, but we're going to pretend for a moment that we didn't know this angle, 31. Okay, so let's say that that's what we're looking for. So I'm going to just rewrite my ratio a little bit here. So I'm going to say the sine of 22, just like I did before, over 41 is equal to the sine of x, I don't know what that is, I'm pretending a minute, over top of the side length, which is opposite that angle, which is 56.4. So if I'm looking for x, which is the measure of angle A, that's how I would set up my ratio. So I'm going to do the same thing, 56.4 times the sine of 22 degrees should be equal to 41 times the sine of x degrees. So the first thing I'll do is divide by 41. So that gives me some number, which I'll type in the calculator and I'll get. So I have 56.4 times the sine of 22, and I'm dividing that by 41. So let me do that. So I have 56.4 times the sine of 22 degrees, and I'm dividing that by 41. And when I do that, I'm getting 0.52 approximately is equal to the sine of x. Well, we already know how to solve that. We're trying to find an angle measure, so I'm going to take the inverse sine of 0.52. So when I take the inverse sine of 0.52, I do get x, and I'm getting x is approximately 31 degrees. Okay, now we already knew that, of course, but we were doing a problem. We were using the law of sines to find an angle. So when I found the angle, I got 31 degrees. And that's how you use the law of sines.